Hi, my name is Jordan Chenault, and today I'll be teaching you about solving linear and quadratic regression. So for this, you're going to have a calculator, just a TI-84, and here's an example problem. The table below lists temperatures measured in Fahrenheit and Celsius. Find the linear and quadratic regression equations and correlation coefficients. State which model, linear or quadratic, best fits the data. Determine the equivalent temperature in Celsius degrees for a body temperature of 98.6 degrees Fahrenheit. So this is our table. Now what we're going to do is we're going to go to Stat on the calculator, and it's going to have Edit, Calc, and Tests. We're just going to hit Enter on the first one on Edit, and then we're going to type all of these different numbers into the L1 and L2. So L1 is going to be the Fahrenheit part of the table, and L2 is going to be the Celsius part.
It's all raceless, but wait, it's the same.
Okay, now after you're done plugging in all the numbers, you're going to get out of that. You're going to go to Second and Quit, and then you're going to go back to Stat, but this time you're going to go to Calc, and you're going to go down to number 4 where it says Lin Reg, and hit Enter. Now you'll see a screen like this, and you're going to go down to Store Reg, and you're going to hit the vars button. Then you're going to go to the right where it says yvars, and then hit Enter on Function and Enter on y1. And then you're just going to go down to Calculate and hit Enter. So we have 3 values. We have the A value, which is 0.5, a lot of 5s, and then a 6. Then you have the B, which is negative 17.78, and then you have R squared, which equals 1, and R, which equals 1. The linear regression is the R squared value, and in order to get the equation, you're just going to plug the A and B values into y equals ax plus b. So in this case, where y equals 0.56 x plus, or actually it's going to be minus 17.78. Kind of ran out of room there. But that's what your equation would be. So your R squared value is your linear regression. Now next we have to find the quadratic regression. So you're just going to go back to Stat, and then you're going to go to Calculate again, but this time you're going to go down to 5 where it's quadratic regression. And then you're going to do the same thing where you go to Store Reg EQ, and you're going to hit vars again. You go to yvars, and then you hit Enter on Function and y1. Then you go down and you calculate. So in this case, our R squared value is also 1. So when both of your regression values equal 1, you're just always going to go to quadratic. So in this case, your equation is y equals ax squared plus bx plus c, just like that. So you're going to plug in the numbers, and it's going to be y equals 6.05 x squared plus 0.56 x minus 17.78. and that would just be your quadratic equation for this.
Teachers, at this next class change,
Okay.
testing is over, so you may resume your regular classroom.
So,
Go back to your regular classroom
once you do that,
for next period. Thank you.
you just... Okay, so if you want to see this on a graph, all you're going to do is go to your y equals spot, and you hit graph. So that's the linear. Okay. Okay, so here's another example problem. The concentration of a medication in a patient's blood as time passes is given by the data in the following table. Find the linear and quadratic regression equations and correlation coefficients. State which model, linear or quadratic, best fits the data. What is the concentration of medicine in the blood after 4 hours have passed? So, our table is on here. And we're just going to do like we did with the last one. We are going to go to stat, and we're going to edit the table. Yeah, and here's a nice little trick. If you don't want, you can't come down here and just hit clear all of them. So you're going to hit clear and then the down arrow, and you can do that on both of them. And that will clear the whole thing really fast.
Done it. I'm sorry.
Okay, so once that's all plugged in, once all of that's plugged in, you're going to quit, you're going to go to stat, you're going to calculate, and you're going to do the same thing. You're going to go to linreg. So you do the same thing. And your R squared value on this one is equal to 8.17. Okay, so you're going to quit again. You go to stat, calculate, 5, then bars, y bars, function, and y1. Then you calculate it, and your quadratic r squared is equal to
You're just gonna have to be in front of the
0.92.
Will you do the same thing you did last time?
Okay, so in this case, your quadratic regression value is closer to 1, so that's the one that you're going to use. So, in this case, you can go to second table,
Can you get my stuff?
or you can go to second table and window, and you have your table set. And your table set, you can start at 4. So then you'll go to your table, and since it starts at 4, so after 4 hours have passed, you're going to have 51.304 milligrams per liter of the medication in your blood.